What's next on my project? Well, there are three things I'd like to work on today, time permitting. One, I'd like to separate the three different graphics I've made so far, so they are all in a single routine and they can be shown together side by side or in a grid. Two, something new that was requested today. George Dishman suggested that I convert this third mapping into something he called a conformal map, which to my understanding stretches the y-coordinate at different values of x away from the isocline of ironic cosmological time, so that the past light cone from here and now is stretched into a straight line. Here's the image George posted of it, and he says he's not sure what time stretching function is needed for this in the Milne version, but perhaps Jonathan could work it out. I'm not sure how complicated that's going to be, but I can work on that, maybe. The third thing I want to do is to take the Minkowski map of the Hubble flow diagram and animate it via Lorentz transformation and see what happens to the other graphs as I do so. A fourth thing that I've been thinking about is to reproduce the little light cones that Ned Wright put into his cosmology tutorial. In particular, I'd be curious about, after the conformal mapping, if the light cones would be all parallel to the central light cone of the central observer. So I think my second goal is the best place to start today. I want to figure out exactly how to stretch this graph differently at each x coordinate to make the light cone marked in black dots into a straight diagonal lines. Now there might be two or more ways to do this. I'm thinking one, we can look at the functions, or two, we can look at the output. And I'll bet you the first option is going to be a lot easier. So if we look at the functions, we remember that we started with points 1 minus x, no, 1 minus y, comma, y, I think. Let me check. Yeah, that's what we did. We mapped that to r, well, we sort of did a double map here. R equals arctangent of y over 1 minus y times square root of the bigger one, wait. Yeah, y squared minus 1 minus y squared, comma, square root of y squared minus 1 minus y squared. And then we shrank that to, we applied the function x comma y goes to x over y comma y. And so that would mean that this would x comma y to x over y comma y would just send it to arctangent of y over 1 minus y comma square root of y squared minus 1 minus y squared, because we're just dividing this by that, so it just gets rid of that. And then to do the conformal mapping, we're going to be taking this thing, how would we do that? Well, actually, we've made it to step 2. We're now looking at the output of step 2, which is, and then what do we need to do to these terms here to make this line straight? And basically, we're going to want to give a scale function of x times our output of y, and comma, and then this is going to be, so actually the arctange of y over 1 minus y is going to be inside that function, because this is our x at this point.